All right, so lesson 2, compound interest. So to distribute interest more than once during a given period of time, blah, blah, blah. What this basically means is we had a formula for simple interest, and technically there's a long way of doing it. The long way would have been on the first problem for the first unit. $1,000 times 0.05, do that. And then do it again, and do it again, and do that 10 times. Well, it just repeats because you're always based on the $1,000. With compound interest, what happens is you earn that first month or first day or first year's interest, but then the second month, instead of being based on the original $1,000, it's based on the $1,000 plus whatever interest you earned. So you're ending up getting interest not on the original amount every time, but the original amount plus the new interest. And then the original amount plus the new interest. And so it's compounding. You're getting interest on the previous amount, which is always building. And what happens is you build interest faster. That's why you invest money in these things, to make money faster, which is good for you. Okay? So here's the formula. It's a little bit more complicated. We did this in the logarithm chapter in algebra 2. So you've all seen this. You can see it's pretty much the same formula. We still have our P, we have our 1 plus, there's our R, and there's our T. The only thing that's new is this M, which I don't know why they use M, because when we did it in algebra 2, we used N for the number of compounding periods. I think that's just a typo because it's usually N. Doesn't really matter. It's just a variable. But it's the number of compounding periods. Okay? I don't know. So, again, I usually use N, but it doesn't really matter. Okay? Now, this is very key. These numbers down here. Most of them are kind of common sense. Annual, 1. Quarterly, well, there's 4 quarters in a dollar. There's 52 weeks in a year. Not too challenging. Semi, it's half, 2 times a year. That one kind of throws people sometimes. And monthly, most of us know there's 12 months a year. I will say this one usually throws people for a loop. Even though there's 4 quarters in a dollar, sometimes people go, oh, quarterly, that's 4. So 12 divided by 4 is 3. So that's 3 times a year. No, it's not. It's 4. There's 4 quarters in a dollar. That's the answer. And then daily, remember, we're using the banking system of 360. Now, when we did this in algebra 2, we used 365 because that is how many days there are in a year. But for the finance unit, since finances are based on what the banks do, we're going to use the 360. All right, so here we go. We're going to get to the calculator in a minute. We're just going to do it with the new formula. All right, so how much money will you have? That is future amount. Okay, so our invested amount is $1,000. Okay, 10%. Okay, I wish this problem would use 5%, so we could have really compared it to the previous problem, but we'll keep it with the 10%. So 1 plus, now remember, 10% is 0.10. Don't forget that. So that goes up here, 0.10. It says compounded annually. That's kind of easy. That's only 1 for 10 years. Okay, so kind of simple. Now, I like to do this one in baby steps if you're doing it the long way, calculator way. So I like to do, I would type this in if this was a different number. Like if this was quarterly, I'd put a 4 there. But we already know what this is. But I would normally just type this in first, hit enter, then add 1. But we know there's going to be 1.1. You can kind of just see that. Whoopsie. That's weird. What is... Okay, my calculator's off. Let's try this again. There we go. It's working. So 1.1 to the power of 10. Oh, I forgot something. Technically, this is 10 times 1. It's still going to be just 10. But if that number was 4 or 360, it would change. Okay? So to the power of 10. Sometimes I hate this calculator. 10 and then times that number out in front, 1,000. And there's our answer. $2,593 and 70, careful with the rounding, 74 cents. So 2593.74. And it's 4 because the third number was a 2, which means you round down, and round down means stay the same. Okay. Now, there's a really cool feature with these calculators. There's a more advanced feature on these, and it's the finance. Okay? So depending on what calculator you have, okay, in class you have a yellow one, but you might have your own personal calculator. So how we get there might be a little bit different, okay, where the buttons are. But we're going to go to our calculator, and we're going to look for apps. Okay? And I'm going to try to scoot this over a little bit. Okay, so we're going to hit apps. We're just going to choose finance. Now remember, this formula is not a really complicated formula. So if you just want to do it the way you did in Algebra 2, the way I just modeled it, it's really easy. But this is just kind of a little bit quicker. So you have this thing called a TVM solver. Okay, the TVM stands for time, value, money. Pretty basic. Okay, so we hit enter. And now we put these numbers in, okay? So a total number of compounding periods. This is, let me get to it, this right here. So in our case, it's just going to be 10. But remember, if this was quarterly, then it would have been 10 times 4. So n in the calculator is whatever goes up here in the exponent. So in our case right here, it's 10. So we just hit 10, okay? Our interest rate. Now, careful here. I just made a big deal in the first two sections about, hey, always change it to a decimal. Notice this says I%. So you're not going to put in 0.10. You're going to actually put in 10 because we're talking about 10%. Present value. Well, that's the amount of money that we're putting in right now, $1,000. Payment. Now, we're not going to do anything here. We're going to put 0. But sometimes people put in like a starting amount in their bank account or their investment thing, and maybe they have $20 a month put into it out of their checking account or their paycheck. If we were doing something like that, the cool thing about this is this can handle that, and we would put that number right here. You know, future value, that's what we're trying to figure out. Okay, and then compounding periods per year. How many are there per year? Well, it's only 1, okay? So we're going to leave this 1 and 1. But again, if it was compounding 4 times a year, we would put 4 in there, and it would change. Now, to calculate the future value, FV, we're just going to hit, if you notice on the enter button here, there's a green solve. So we're going to hit alpha, enter. And lo and behold, there's our number again. Now, notice it does have a negative number. Don't worry about that. That has to do with banking and accounting and debits and credits. But don't worry, we're not losing money. This is just the number 2593.74, just like we had right here. Okay, so once again, you know, this is a quick and easy way to do it. And this one, you know, this one was even simpler this way because it was just 10 and 1. But if this would have been 4 or 360, you know, there'd be a little bit more math and crunching to do, but you could have done that all right here. Personally, I think when you're first doing the first few, it's kind of nice to do it this way and this way, just to make sure you're doing it right here and you're getting the same answer. It's a good way to practice, okay? And so there's all that in there. So let's do it again with a new one, all right? So if you deposit $1,600 in the bank, okay, well, that's the present value, 1,600, okay? That's right here. 2%, so we're just going to put 2 here. Remember, not 0.02, okay? 2% is just 2. Compounded quarterly, okay, for 5 years. All right, so payment, we're not going to do, we're going to keep that 0. Future value, we're going to calculate this. Now, the payments per year. Quarterly, I actually lied before. It's not going to be the number up in the NT because that is overall. This is payments per year. So remember, if it's quarterly, then, let's see. Yeah, that's that one. So actually this will be. So payments per year is going to be 4. And the calculator, when you put it in, it's going to automatically put 4 in there for you. Oh, my bad. I wrote that in the wrong place, didn't I? Silly me. So when you put this one in the calculator, this one will automatically change from a 1 to a 4. Now, what is our n? Okay, well, that is where we do this. So that's that actual number up in the upper, that's our exponent. This is going to be the 4 times 5. 4 times per year, 4 5 years. So this number here is going to be 20. Okay, so let's do that. So we come up here. We don't have to erase anything. It just overwrites. So our number here is going to be 20. We put that in. We come down here and we change this to 2. Present value, the principal, we're going to change to 1600. Now, technically, if we made this a negative 1600, we would get a positive number on the end. We don't have to worry about that as long as you remember to put everything in positive in your answer. Payment, we're not going to do anything there. And remember, watch here. As soon as I hit 4 and I hit enter, watch what happens to CY. Boom, it changes automatically. Then we just go back up to future value. We hit alpha solve. And there's our number right there. And again, we look at the 83. We look at the number next to it. The 2 tells us to round down, which means stay the same. So our money we have at the end is $1,767.83. So real quickly, not that we're going to crunch it, but if we did the actual formula the way it would be 1600. Okay. Then it would be our 1 plus. Our rate would be 0.02. Quarterly would be here 4. And this would be that 4 times 5. 20. Now again, if I was doing this in the calculator, I would just start by typing this in the calculator, 0.02 divided by 4, hit enter. Add 1, hit enter, raise it to the power of 20, hit enter, and then multiply by 1600. But you can see how this is quite the time saver, no pun intended. All right, so I am fine with whatever method you're more comfortable with. Some people are more comfortable with just, using the formula and crunching. It's up to you. You're not going to be graded on process. All right, another one. We'll do 2 more of these. That's it. How much money would you have in the bank today? How much money would you have to put in the bank? So now we're going to work backwards, and that's where the formula is more complicated. So that's where this is really nice. So you will have $13.50 in the future. So that means we're going to put $13.50 here in the future value. Again, this is where you have to pay attention. We're going to calculate this time. Okay. Now it says 6.2%. It says compounded monthly. So that's our 12 payments per year. Compounding periods per year. And it says right here, why? For year. So how many times in 1 year? We're always going to leave the 0 in these problems. Okay. Unless we're going to add something, but we're not usually going to do that in this class. Now, the most important thing here that we have to do a little thinking on here is n. Okay? So it's 3 years. Okay? Times 12. So that's 36. But the cool thing about this calculator, wow, that was a bad word, calculator, is let's say we had something crazy like 12 times 360. You don't have to go off to the side and type into another calculator, 12 times 360. You can literally just type in, we know this is 36, but you could type in right here, 3 times 12. And when you hit enter, it just does the math for you. So if you had something bigger like 12 years, compounded, daily, 360, you could just type that in there. Okay, so interest is 6.2. Present value, we just skip that. Don't clear it out. If you clear it out, it won't let you go on. So just leave that alone for right now. Payment, we're leaving 0. Future value, we're going to put in 1350. Present value, we're going to change to 12. And again, as soon as we do that, boom, CY changes also. So we're going to go up to present value and hit alpha or green, enter. And there's our answer. Now, careful on this one. Notice, here's my 2 decimal places, 40, but now we finally have a number bigger than 5. So we're going to round this to 41 cents. So the amount of money we need to invest is $1,121.41, rounded up from 40. And example 4. So when you were born, your parents put your gift money into a bank account. The account started with $462. That is the present value. Now, it happened in the past, so is it really present value? No. But in terms of the account, that was the starting amount. So even though it was in the past, we call it present value. Don't get hung up on that. On your 18th birthday, you had $1,358. Well, that's the future value. So that goes in here, $1,358. If the account was compounded weekly, that's 52. What interest rate were you getting? Ooh, interesting. No pun intended. So our payment, we're leaving 0. We're not making these complicated. Okay. It says weekly, there's 52 weeks in a year. So that means there's 52 compounding periods per year. So we put 52 in here, and again, when we put it in here, it will automatically change here. We are calculating the interest rate. Now remember, N is always a tricky part. You just got to think about this for a little bit. They put in there your birthday. So that means it was in there for 18 years. Times how many times per year? So 52 for 18 years. Now, this is one of those big numbers. So let's see it in action. Go to our calculator. We go back up to number. 52 times 18. It does it for us right there. Interest rate, we're trying to solve that. Leave it with the number, skip it, and come back. Present value, even though it was the past, they put in $462. Kind of a strange amount. Who knows why? Payment, we're leaving it 0. They're not putting money in every month. Future value, okay. Wow, that's weird. Very close, but different. So we're going to change it to 1358 instead of 1350. And then payments per year is 52. And as soon as we hit enter, watch CY change. Boom. We go back up to interest, and we're going to do the same thing. Alpha south, green, enter. Something changed. Okay, this might be one of those ones when unfortunately we have to put in a negative, which seems kind of weird, but let's see if that is what it is. They might be picky on this one. Okay, there it is. So in this case, if you get that error, just change the amount to a negative, because technically, again, in accounting, this should be a negative, which would give us a positive here. Most of the calculations, it doesn't matter. We just throw it away. But in this case, when we're working backwards for the interest rate, it can't handle it. Okay? So you just got to change this to a negative. And so we get 5.99. Always go out 2 places. So that's 5.99%. And we're going 2 places because if we rounded, this would make it go to 6, and we want to have a decimal, so we put 5.99%. That's it.